What we're going to talk about is the Wyoming Coal to Fuels. And specifically, it's a joint venture between Homeland Fuels and Remediation Earth. I'm not going to go into a lot into our history, it's more at the end. I want to get into the meat of it. What are we doing differently than most of the companies, and why are we going to be successful? One of the things I've learned over the many years is that we're avoiding the large, expensive, well-established technology providers, equipment providers. They seem to take very long, their prices are very high. We're trying to be more of a guerrilla company, moving quickly and getting the solutions in early. We're going to be working with those technologies we have selected by giving development money to encourage them to develop at a quicker rate. We're especially been looking at those technologists who have been able to integrate successfully multiple target technologies together already into a platform that has been tested. And most importantly, the beneficial use of CO2 in EOR and CO2 fracking. We're going to be looking at cleaning up the syngas in some novel ways. The right coal from the WRI people, Don Collins is here, to condition the coal up front to make it more reactive and remove the moisture. Their CAT process, which allows us to take CO2 and to make hydrocarbons. Very, very important to this whole process is cryogenic CO2 separation, where we pull the CO2 out and put it up here. Yeah, and we put it into a liquefied form that can be sold to individuals such as Linde and others. Very, very important is developing the next generation of VPSA, vacuum pressure swing absorbers, because right now to make oxygen for all these gasification plants, we're rather limited to around 93% oxygen, and the other 5-6% of inerts are the things that catch up to you in the FT system and the recycle and cause problems. So we're working very closely with AbsorbTech to develop the new VPSAs that are 99% oxygen. And also NOx control. Some of my dear friends own technology that are the next step for taking out trace ppm of NOx, kind of like an SCR, but about half the cost. So we'll be incorporating those technologies also. We're looking at the fact that the ultra-clean syngas is pivotal. With the FT type of system we're using, which is a tubular fixed bed, we must be at less than 30 parts per billion in the sulfurs. We are also making a hybrid CTL system here that's going to be coal to liquids, but it's going to have a portion of it that's GTL. And the reason for that is that we want to model this whole plant so that we make the bigger systems, which are going to be in the order of 2,500 tons per day each, more towards Gillette area. We want to be able to use the coal bed methane. So this is a good way to suss things out urgently. Again, cryogenic removal for EOR and CO2 fracking. We're working with a group where we have decided to make Ftane, which is a distillate blend stock. We're not going all the way to FT diesel. We see more use and more of a market for this blending stock. Principally because it has 0 sulfur, 0 aromatics, and 0 nitrogen, a very high cetane number. Somebody may ask, where can this be used? There are certain places where they're using a naphthenic-based crude, which makes a naphthenic-based diesel with a very, very low cetane numbers, 32 to 36, and by putting this cetane enhancer in here, you can bring it up very, very quickly to 44, 46. Very important to us also is the fact that this synthetic product has an average of around 40% less emissions when burned in an identical diesel engine. We have been doing a lot of work in the background, and we have chosen our EPC, which is going to be URS, specifically the Air Quality Control Power Group in Denver. And as everybody was aware, they're being acquired now, and we chose them for their very specific experience in these size plants, CTL and GTL. Here's a little cartoon showing how much the reduction is based on this type of fuel. And the average is somewhere between 35 to 40%. Our commercialization program, we're originally going to apply for a $4.5 million unsolicited grant through the state for our feed studies. We're pursuing 2 financing plans right now for the first system. One is organized and one is pretty much complete and in place. We have Piper Jaffray who wants to fund the first plant. We've chosen the Cheyenne, Wyoming site, Swan Ranch, and we have actually taken option on the property. The site will be cash flow positive, and not only the fuel cells, but it's the CO2 byproduct sales that help quite a bit. We're looking for an AIG warranty on production for backup, and it's going to be ostensibly a 400 ton per day coal augmented with 150 tons per day natural gas, on the order of around 1,400 barrels per day. And by us using the F-tane distillate blend stock, we'll have a cutoff of somewhere around 90% F-tane and 10% naphtha. We see construction somewhere to late Q2 2015 with a CapEx on about $190 million. One of the things I'm particularly interested in is the Job Training Center and Development Center for Wyoming University and co-ops and interns. I've had them for many, many years in other positions, and I think that we need to retain those individuals getting out of Wyoming universities and keep them here, and so we will have simulation sites and other things to attract them. The full-scale plants will be approximately 2,500 tons per day. At this point, we're envisioning 4 plants in the Powder River Basin area south of Gillette, and each one of those plants will make on the order of around 7,000 barrels a day. What's near and dear to me is that we'll generate somewhere around 2.5 million tons a year of CO2, liquid CO2. Obviously, in any of these projects, there's risks, and we are looking at all their various types and how to take care of them, and anticipate them, and minimize them. And probably litigation and public opposition. There's been a lot of people saying, we don't like coal, we don't agree with that. We think that coal is a clean feedstock, and we aim to show that. Put together a very, very simple schedule, abbreviated. There's a more complex one at the end. But basically what it's showing, and it doesn't show here, we've done a whole bunch of work in a previous year here, but this is, orange line is where we are now. And what our plan is to do a private placement memorandum to raise some money for development while the bigger money comes in. And these are the kind of tasks that we're going to be doing. But bottom line is, we're looking somewhere around October, November timeframe of 2016 to be up and running, God willing. Along my first slide of looking for people who have integrated multiple technologies together already, we have been told by the funders that look for something that has these multiple technologies already proven to minimize risk. This is a TRI gasifier, and that in fact has the gasifier, the gas cleanup section, and the FT section already put together. And in fact, here are these various parts. And obviously, we're not using biomass, but coal, you got your steam reformer, you got your carbon trim cell, and you got your Fischer-Tropsch over here. So this is something that's demonstratable. And at the end of the month, in about 4 or 5 weeks, we actually will be running Powder River Basin coal, and we will be bringing in conditioned coal from the WRI process, the right coal process, to actually compare and contrast how much of an improvement there is by putting that coal through the process. I put this up, and I typically don't go into such detail, but the reason is there's many, many people in here who are technical, and there's engineers, and I'll simplify this before it's released. But I want to show you that the right coal process, again, will be drying the coal somewhere at 5% or so, and thereby tremendously increasing the reactivity of the coal. We'll come into the TRI gasifier, steam reformer, and the TRI carbon trim cell, and very, very simply, we're going to go through several stages of gas cleanup. We'll be doing our compression stage somewhere here and pull out the carbonyl sulfide, but more importantly is this area over here I want to talk about because it may be more near to the carbon sequestration people and other uses. Originally, we're going to put a small amine system in here and have the carbon capture, cryogenic carbon capture system in parallel with it to prove it out to minimize risk. And after we show, in fact, that the cryogenic carbon capture system can do the job alone, then we will minimize amine on future plants. The purpose of that is that we will remove this CO2 as a cryogenic liquid by a cryogenic method, and then we will be selling it to Linde or others, whoever wants it, for EOR and for CO2 fracking applications. Once it comes out, it'll be polished and then go into the FT unit. And then here's where this basic idea of a hybrid plant is. The top section is your typical CTL, where you got your gasifier going to your FT unit. The bottom section, which I call the supplementation using natural gas, we bring the natural gas in, do a partial oxidation with a sweet shift, and bottom line, what we're doing is we're making a whole bunch of hydrogen that we can use for upgrading this product. And then it allows us to go kind of the back way and adjust the hydrogen CO ratio very accurately. For using FT, if you're going to be making good diesel fuels, etc., you want a ratio of around 2.1 to 1. And this is a pretty neat way of really adjusting it very finely. Our number one alternative is to use the Emery Energy gasifier with Ben Phillips here. Ben has been working with us probably for a year and a half on a project in Illinois, which is a little bit smaller, which is a CTL plant with natural gas supplementation. We're presently integrating Ben's technology with some of these other unit operations, so it may be very well as we get farther along that his becomes the number one technology. Basically very similar, gasification, cleaning it up, FT, product upgrade, and still in the circuit for taking natural gas. AbsorbTech, there's a picture of the VPSA we're working on for 99% purity of oxygen. The right coal gasification process, I'll just simplify it. It really has its benefits in removing the moisture, especially in dry areas like Wyoming, so we can use the moisture where we want to use it. It increases the reactivity of the coal, and it takes out these guys ahead of time, mercury, arsenic, and selenium. And so that will be what we'll be using going forward. Uh-oh. Hey, sorry. This is just a very simple slide to show you the example of taking regular raw coal and drying it and partially drying it using waste heat versus the right coal process and total ownership cost. And if you do the numbers, there's about a 40% savings in time from a gasifier using this conditioned type coal. I won't get into a lot of details, but the CAT process, which we'll be using as an alternative to processing CO2 into fuel, is a pretty unique method where there's two basic bacteria, and one of them takes CO2 and oxygen, and one of them takes the waste products from these guys, and together they make a hydrocarbon that can be processed. Very simply on the TRI gasifier, it's a two-stage. You have your gasification here. A little unique to them is it's an indirect fired, where there's a pulse heaters here and a deep fluidized bed. And then there's a trim cell here that takes care of the oil and the various tars and other things. So it's a different approach to doing the gasification. It's a two-stage. And the pulse heater is really the kind of the unique part of it all, where we take the tail gas from the FT, put it through here, and it's combusted, and it keeps moving back and forth and combusting itself and keeping those tubes clean. Very, very high efficiency and high heat flux coming out. So that's kind of the basis for this approach. Going to SES, who is the cryogenic carbon capture company we're working with. As I said earlier on the first slide, we're looking for people that are somewhere at the late pilot demonstration and early commercial demonstration stage. Well, they fit right there, because here's where they are right now, and we feel comfortable that they'll be able to move up to the commercial stage. Right now, they're putting together a 3-skid unit that's going to be going to a couple different places, and we're trying to get one to go to Mountain Cement in the next 3 months to actually do some carbon capture cryogenically. One of the things that I liked from early on is the fact that this approach is about half the cost of amine. It's bolt-on technology, and it not only takes the CO2, but I think with some simple modifications we'll be able to take out NOx, which is one of the concerns I have. I spent 9 years early in my career with Linde designing and building and operating cryogenic plants, large ones in Buffalo. And I believe that this technology, if modified slightly, will not only remove the CO2, but the NOx. And we have done some research to determine that for EOR, that if you have a liquid CO2 and you have certain ratios of NOx and H2S, you can actually increase some of the characteristics of EOR positively. Just want to show you the parasitic loads, again, compared to amine, and you can see that there's quite a savings. One of the interesting specs has to do with the EOR spec. Interestingly, if you use this pure CO2 for food and beverages and other things, we're not going there. What we're looking at is the EOR spec, and it allows you to have a certain amount of H2S and NOx and other constituents and still be considered acceptable. We're talking about the financing, obviously choosing an owner's engineer. We have been, Michael Halleck, who's here, has been very busy. He just visited with Sinclair Refinery. We've been giving samples of this F-10 Plus out, and they're talking about potentially giving us an LOI for this material in the next 7 to 10 days. We feel that the secret to success with a project like this is a 3-legged stool: the feedstock, the technology, and the offtake agreements. So we've been spending a lot of time on those 3 areas. We think that the cetane enhancer will go pretty far here, and it'll benefit by having jobs in the area and improving the job training and retaining good students. This is a very, very simple, extremely simple analysis of the economics. And one can see that by starting out with 400 tons per day of coal and 150 tons per day of CO2, you're somewhere around 18 million gallons a year. And when you factor all these various issues, you come out at the bottom of somewhere around $1.50 per gallon total operating costs. So if one subtracts 320 from the 150, you can see the approximate area we're starting out with. And the carbon capture costs are in here, buried and nested. Again, we intend to roll out at least 4 plants, and we want to have them located close to the mine mouths, and we want to also be close to the EOR opportunities. We're talking to various groups about raising their money and getting permits done and that type of thing. And obviously, very important to us is securing the long-term coal feedstocks agreements. Right now we're talking to Peabody for the Whittle-Anderson seam, which is around 80 miles south of Gillette. It's around a 180-mile trip here, and Michael's working very, very hard to try to get it delivered, but everybody's saying that you can't have deliver less than a unit train of 100 cars minimum, so we're trying to figure out a different way of doing that. Partners, again, Homeland Fuels has much experience in development projects. Some of the ongoing projects right now. Vic Gatto, who is the founder and president, is my partner in this JV. REI, which is our company, a lot of experience in thermal conversion technologies and engineering and operations of plants. These are some of the type of equipment I put all over the world in different refineries, automated equipment. The more complex schedule, again, showing some of the work before we started, again, reinforcing the fact that we're down around November 17th. Thank you.
Questions from the board?
You might have said this, but the diesel that you produce, is that usable in today's vehicles?
It's a distillate blend stock. It's a distillate blend stock that will be blended in around 20 to 25% proportion with regular diesel stock. We can go the extra step and go all the way to ASTM D975, but the costs are excessive. And 110 fractionation column and fractionation column and associated costs. And the problem is when you go to FT diesel all the way, you reduce your cetane down from somewhere 72 to 73. So people are saying, hey, what are you doing, Danny? Stay up to 82 or so, because we need the cetane. So that's why we've kind of cut it off before that way.
Danny, can you talk about the FT technology? Isn't that just a recent announcement where the Chinese airline is scaling that up to provide jet fuel?
Yeah, they're going to be buying, it's $1 billion contract, and I forget how many gallons, but they're going to be buying for the airline this actually combination of TRI gasifier, the cleanup, and the EFT back end, FT system. So this is all proven stuff, and there are multiple people buying large amounts now using this setup.
Just a quick question.
Sure.
Will your presentation be available for us?
Yes. All I need to do is sanitize the two slides that are a little bit too over the top on block flow diagrams.
Yeah, the questions I had were, and I couldn't, it went so fast I couldn't get the numbers, but I was trying to put in my head the tons of coal input for your, for your module that you're planning, the fuel or the liquids output, and then if you had those two numbers, and then some idea of what your tons of CO2 produced.
Sure.
If you had that in your head.
Yeah. In general, for CTL using PRB coal, you're going to find out that normally without using the right coal process, you're going to be somewhere around 1.7 barrels per ton. By using the right coal process, you're going to take PRB coal, which is nominally at 8,800 BTUs, and you're going to bring it up to somewhere around 12,200. In that particular case, you're going to now put out about 2 barrels per ton. So in the case of the natural gas supplementation, you're going to be putting out 4.25 barrels per ton of natural gas. So if we take an example of this 400 ton per day plant with 150 tons of natural gas, we then multiply 400 times the 2 plus 150 times 4.25, which comes out to about 1,430 barrels a day. Because we are making F-tane, which is a distillate blend stock, and we're not going all the way to diesel, we'll have a 90-10 cutoff, so about 90% of it will be F-tane, and about 10% of it will be naphtha. Now when it comes to the emissions, you get, using PRB coal and this technology, 0.8 tons of CO2 per ton of PRB coal after it's put through the right coal process, and you get 0.05 tons of CO2 from natural gas in the CO2, in the natural gas augmentation part of the process. So that comes out to be about 300 tons a day.